Hi there. So my name is Fabian. By night, I like to stand in front of buildings and check people's tickets. By day, I'm a data scientist for Ravelin. And this talk is going to be very much on the applied side of applied machine learning, because I would like to talk about 1.5 years at Ravelin, 1.25 years for me of deploying machine learning models and what we've learned along the way. So I'm going to super briefly go over what we do. We're a fraud detection company. So we sit in the checkout process of most of our clients, and we ingest all this data about their customers. So it may be base data, like the registration, their name, their email, its payment methods, it's the details of their order, but it also goes into sort of details about their devices, about IPs, all these kinds of things. Ingest all of this through our API and then use a combination of machine learning, of a lot of network and graph analysis, and then of what we call the blacklist, which is basically our combined knowledge of fraud in the world, to in the end put out a score and say, we think this is the probability of that particular event being fraudy, or rather that particular person trying to buy something with a stolen credit card. And machine learning is very much at the heart of this, and there are a couple of sort of unique challenges for us. So in contrast to some of the other talks, particularly the first talk maybe we've heard, we have quite a few different clients, each from different industries, and they all come with their own data and their own quirks. And like many companies in our sort of area, we have limited control about over the data that comes into our systems. And most importantly, having these different clients from different industries means we're running different models at the same time, all the time. So we may have a very big, very mature client, and they will then be on their own model, which is custom tailored for them. Or you may have a client which is a bit newer, but they're from an industry we know well, right? So we may run a model that specializes on the taxi industry, or food delivery industry. And then we may have very new clients, and they may go in a very general model that just reflects the general things that we know about fraud. And then the other special thing about us maybe is we have very long feedback cycles. So what happens is someone steals a credit card, and then at some point the person notices, oh, my credit card was stolen. And they go to their bank, and the bank goes to Visa, MasterCard, and they go to the merchant goes to us. And by the end of this process, up to 120 days have gone by until we've learned what was actually going on. So even though we've only been around for 1.5 years, we've really had to build this automated solution to deploy a lot of models in this time, and basically guarantee good performance out the door, because it takes a long time for us to find out whether we were right in the real world. And I want to talk a bit about lessons learned from this process, and I want to take them in order. So I'm going to go from infrastructure to data to training and evaluating a model to deploying a model. And start with the infrastructure. And really one of the first things we've learned is your pipeline comes first, no matter what you do. Because really, trusting your model means trusting the underlying code. And it depends a bit on what data scientist from what field you talk to. But I think there's still a few fields where we're really struggling with basic concepts like code review, like testing, all these things. And these should really be in place, and we actually believe they should be in place for every single step of your pipeline. So that applies to data cleaning, to hyperparameter tuning, model training, validation, but then also to things like comparing your model to the current model. Because there's a temptation to go, well, so we have this pipeline and it gave us the data and we trained a model, and now someone's just going to go off and compare it to another model and then tell us whether it's any good. And really, if that last part isn't quality checked, then you might as well not check all the other parts. So we've really come to put absolutely everything we do into a pipeline. And so what we've added to this and what we found quite useful is we end our pipeline in a report. And we simply use NB-convert, so basically the programmatic way of creating Jupyter notebooks. Create a notebook with a summary of all the things that we've learned about the current model that we've just built, strip out the code, send it to Slack. So we come in the morning and there's a message for us in Slack going, we've trained a new model for client XYZ. Here are the stats compared to the current live model, which is a really nice thing to have. The one thing I would do differently if I were to rebuild that pipeline is I would try and really build it with multiple models in mind. So it's one thing to build one pipeline that puts together your data and builds one model, but really you're going to reuse that pipeline again and again for your subsequent models. And a very simple example of that is just train test splitting. So we used to start off with a very sort of vanilla implementation of just shuffle split, or the same applies for k-fold split, really. And you take your data and you split it into train and test, and I've sort of shown this here by showing training data as black pixels and test data as white pixels. And then you go in sort of a month later and your data has grown a tiny bit, and so you do the same thing again, and it's basically a shuffling procedure, right? And then you have these two models trained on two different sets of data and you want to compare them, and you find out, oh, actually the overlap between my data for the two models is tiny. So the amount of data I have that neither model has been trained on is a lot smaller than I would like it to be. And so one solution for that is to just use, for example, label-based splits. So we use something like a customer ID, which is persistent over time, hash it, and then in order to produce multiple faults, for example, you could just rehash it using universal hashing. But that way you can guarantee that your new test set contains your old test set and your new training set contains your old training set. And it's really just a small example for building your pipeline in a way that doesn't just take account of one model, but of multiple generations of models. Cool, so you've got your pipeline, you trust your code. The next thing is you want to trust your data. And chances are, this isn't true for everyone, but for us it is, that your pipeline looks a bit like this. So you have a database that your client or whatever you get for your data from feeds data into. And then you have a live track, and that live track basically feeds single feature vectors to your currently active machine learning model. And then you have an offline track. And in the offline track, you basically go back through time, you create all these feature vectors as they would have been, put them into a bit matrix, and use it to train the next generation of your model. And there, as you're all aware, I think there are quite a few places where this can go wrong. So you could get the wrong data in, or something about your sort of feature creation is wrong, something about the way you roll back in time is wrong. And we've actually found that doing something very simple, which is creating asserts on your features, helps a lot. And that's because it helps at multiple different places. So it helps at the 3 places I mentioned. So maybe a bug in your code, maybe a bug in the data coming in. But it also helps with something that maybe isn't as obvious, and that is assumptions in your data, right? So say we create this feature, time since registration. And we try to look at a single customer and we go, so old customers who've been around for a long time, we can probably trust them more. So let's just take the time since the registration, and then we create this feature, and it should always be, larger than 0, and it should increase with time. But the implicit assumption in this that we probably hadn't thought about is that our client's workflow is customer registers, customer places an order, customer pays, all these things, but registration comes first. And now what happens is we have a client sign up where actually someone buys something on their website, places an order, pays for it, and then they ask, hey, do you want to register? And all of a sudden we have these events which are actually before their registration time, right? And this is a really good way of catching this, because not only does it test your code, but it also tests the assumptions that you've made about certain features. And then really everything else in this department can be summed up as log all the things, right? Because even if your feature creation works perfectly and your features are fine, there's the case where your features that you train on just don't correspond to what's happening in the real world anymore, right? So maybe you have a client who used to sell a lot of really cheap products. Now they sell a few really expensive products. And there's the chance that you'll end up training on the data that's mainly made up of cheap products, and you end up with a very skewed distribution. So what you really want to do is you want to log everything that goes into your machine learning model in life. And we found Google Bigquery very, very useful for this, because it's very nicely schemed and is very easy and relatively cheap actually to store huge amounts of data and then pay as you take them out. And this is exactly the kind of thing where you want to store, and then use a tiny bit to compare your live data to your training data and say, do my distributions actually still match? And then part 2 of log all the things is of course, you also want to log everything that comes out of your machine learning model and is predicted by it, and you want to log your client's response to it. And that is very much related to your labels, and it's this whole very complicated idea of the counterfactual, right? So say that we've got a couple of people go through our machine learning model now, and we say, you look bad, you look good, you look bad, and then you look particularly bad very early on. And so we're going to recommend that our client does not let you buy anything with your credit card, right? That's fine, this is what we're here to do. But one of the consequences of this is because this person could never buy anything, we're never ever going to get hard evidence that they were a bad guy. Right. And this is a very complicated problem, and it probably deserves a whole talk of its own. But I guess the only thing I want to say here is you really want to avoid training on these as good people, and you want to think about how you want to weight them in your training set. And the only way you can even start thinking about this is by logging everything that comes out of your machine learning model and everything your client does with that kind of information. Cool, so we trust our code, we trust our data, and then, well, let's just go ahead and train a model, right? So we've done this, and then there's some measure of performance that we do, and I'm going to do a slight cop-out here and actually not talk about that too much. And the reason I've decided to not talk about this too much is that I think there's actually a lot of information out there about it. It's not the most interesting part, except for maybe you want to make sure whatever metric you use, that of course the test data you use represents the real world, which again might be a distribution thing. I'm more interested, and I'm going to talk about what we've learned about manual review. So we actually really believe that manual review is a super valuable thing. And every time we've done a deep dive into our data and the results of our models, we've learned things that we absolutely hadn't expected. But here's the thing, manual review also is maybe the single most expensive thing in terms of time investment that you can do, right? And so what we've come up with in the end is, yes, you want to do manual review, in our opinion, but you want to build a structured system around it. And there's a lot of automation you can do around manual review. So I was talking about this report we create. Part of the report is saying, here are cases where your current model disagrees with your new model. Why don't you look at them? And because the report is HTML, we just include a couple of hyperlinks to a dashboard. We can click on them, we can immediately look at them. And you can go as fancy as you want. You can cluster them to spread them out a bit, but you've basically, and you could still always do a deep dive, right? But you've taken away this first step of going, what should I even look at? And then the other thing is, the problem about manual review is you're learning a lot, but it's in a single data scientist head. And what you want is a way to get what you've learned out of that head and somehow into code. And perhaps the most successful way for that we figured out so far is that we've created a little library which allows us to write these roles. So what you see here, for example, is something called Sleeper Card 002, I think, which is a person who's been around for 3 months, has sort of acted normally, and then all of a sudden adds 5 different cards with 5 different names. And this library is very much built on Faker, so to get all the personal information. And then all the details that we don't add in are added in as the average cases of a particular client. And so what this allows us to do is it allows us to do manual review extract some sort of general knowledge, turn it into a shape, a concept, and then use that concept in the pipeline as an assert. And it's not immediately obvious how you could put that into, say, a pure performance measure, but it's absolutely useful even as an assert, even scoring a couple of randomized versions of these cases you've seen and see how your models develop, right? You've caught these kinds of people earlier, but you train a new model, does it still catch them? Well, this is the kind of thing that helps you tell this really easily. And then there's another thing I want to talk about, which has actually been mentioned in the first talk, and that is, even if your overall performance is good, outliers really, really matter. And this is a shout out to one of my favorite AI talks ever, which is at GDC 2015 by Kimberly Vall. And Kimberly Vall is a cognitive scientist, and she works on AI and she writes AI for games, which is a pretty kick-ass combination, I think. And this talk is about producing AI for one of her games. And her takeaway basically is people are going to judge your game AI by the stupidest thing it does. So if you're into gaming, you might know these sort of Half-Life 2 examples of jumping on people's heads and they don't care, right? That sort of thing. And I really believe, even though we're in a B2B business and we actually get to talk to analysts and show them our stats and our data, this still hugely matters. Outliers hugely matter. And so to give you an example of this, say you've got a person who signs up and uses only curse names as their first and last name, right? There are going to be very few of those people. They're not going to skew your overall performance. But an analyst is going to look at this and say, censored with 2 credit cards? Like, no way, that's a good guy. And immediately they're going to think your product is a bit silly, right? And so you want to be aware of this. And the way this works for us usually is we learn about this through manual review or from a client directly. And then we turn it into these cases, into these asserts I was talking about earlier. So that's a very nice system to make the most out of manual review and feedback. So you trust your code, you trust your data, you've done some model evaluation, you want to roll it out. And the first thing I want to say is congratulations. In our experience, you're 80% of the way at this point. If you've done it right, we've actually very rarely have had to go back at this point. The only thing I will say is do it gradually. So if you have 2 models and they aren't too different and you have enough data, then we found that on a very high level it actually helps to go and calibrate the second model to the output range of the first model. And then just slowly shift over. So give it 5% a day, give it 10% the next day, 25, 50, and so on. And then instead of spending a week just staring at the numbers as they come in, make sure you have good instrumentation that you can trust. And this is something that you can play war games around really nicely, for example, and make sure that if your results are very unexpected and the distribution just goes off the charts, that you'll be told about it. And if you trust that system, then you won't spend days and days just reloading some dashboard. And that's basically it, except I'm going to leave you with one last thing that we've very much learned the hard way, I think, which is train often, ship often. So in software, there's this concept of continuous delivery. And I don't actually think that applies one-to-one to machine learning. But what we've definitely experienced is that there's a temptation to go, my model works, clients are not complaining, I'm just going to leave it and build all this interesting stuff. Right? And we did that for a while. So our first generation models was doing really well, and then we just went off and built a feature and another feature and another feature and changed a bit about the data cleaning in the pipeline and did this and that. And then when we deployed, it was really, really painful. And it's really painful because the differences between your models are so big. And because if you've changed 15 things and one thing doesn't look quite right, it's really hard to tell which thing it is. And also the other part is just that whole procedure we talked about, that whole pipeline. You want to get accustomed to it. You want to just get comfortable with it. And so we've really since have gotten into the habit of shipping after small changes, trying to have small increments. It's much easier to make one model look like the other, your clients won't notice, and you'll just feel a lot more comfortable in the whole process. Yeah, that's it. There's this really good article, PDF, paper, whatever you want to call it, which probably most of you have read by now, but it contains a lot of this advice and more. Is definitely very highly recommended. Those are my 5 points, and that's all I get.